Okay, so we're going to use 4 here, right? It's not really the point that I told you what would work already. The point is for you to get down to the reduced result, right? So bring down 1. I'm going to do this kind of quicker. 1 times 4 is 4. Add that down. 1 times 4 is 4 again. Add that down. And then negative 2 times 4 is negative 8. Okay, so, I mean, we already knew this, right? We already knew we were going to get a remainder of 0. So we know that 4 is a 0. The point, though, is what we got here. So notice that we get x squared plus x minus 2 here. So different than the ones that I've done before, I actually think this does factor. Okay, so if you used quadratic formula, it's not incorrect. It's just that you do need to look out for things that actually do factor, okay, because when they do, it can be a lot quicker and easier. Okay, there are factors of negative 2 that add up to 1. What are they? Plus 2, right, and minus 1. Okay, so this equals that, right? In other words, I get negative 2 and x equals 1, okay? And I'm actually finished, except for writing my answer. So here is the factored form, right? I started off with f of x equals x cubed minus 3x squared minus 6x plus 8. So let's talk about what 3 parts I got. So what was my 4 going to look like? X minus 4, right? I got my other 2 pieces here, right? X plus 2, x minus 1. Okay, so that's part of what I asked for. So if you didn't quite have the last 2 things factored out, then you just need to kind of make that adjustment. Okay, and then the 3 zeros, all of which are actually nice in this one. The 3 zeros were 4, negative 2, and what else? 1. Okay, now would it have been wrong to do quadratic formula? I already said no, right? So if you did quadratic formula, you should have still gotten negative 2 and 1, as long as you did it right and you worked it out and simplified it. So either way, it really works, but just notice how that was probably quicker if you noticed that it would factor. Okay, so let's look at the graph real quick and then I'll take your question. So here's the graph. So I want to just confirm that you can always check your work on the graph, right? So notice we thought the zeros were what? 4, negative 2, and 1, and where does it look like it crosses? 4, 1, and negative 2, right? Perfectly where we thought that it did. It doesn't look like it crosses at any decimal values. So that's it, right? We got 3 zeros, and we were expecting 3 to begin with, because why again? Because it was a cubed, yes. Okay, what was your question?
So when you get the x squared plus x minus 2, you can use the box on that too, right? That
yes.
Okay.
Yeah, that's just another method of factoring. So yeah, you can totally use that. But just remember, when it doesn't work, use quadratic formula. Okay, so just don't forget about factoring. Quadratic formula is great, but it's a little tedious. Sometimes we don't maybe want to use it all the time. All right, so let's do one more, and that'll be, I think, good for the day. So let's say that I tell you that 2 and x equals negative 2 are zeros of g of x equals x to the 4th plus x minus 20. And I want you to find the other zeros and fully factor g of x. So same thing as before. What do you notice is different though? It's 4th power, which means we're expecting how many answers total?
4.
We're expecting 4 answers, right? So I'm going to say we expect at most 4 answers. So I already gave you 2 of them, so essentially you're just looking for 2 more of them, right? Okay, so let's start off with the first one. It doesn't really matter which one you start off with. You'll get the same end result no matter what, just your middle steps might look different. But I say you need to be cautious with synthetic division. Why do I say that? We're skipping all kinds of terms actually here, right? And actually change this to a squared right before we start. So it should be x to the 4th plus x squared minus 20 for it to work nicely. But we still have missing terms, right? We have a 1 for the x to the 4th. We skipped x cubed. We have a 1 for x squared. We skipped x to the first. Don't forget about that guy, right? X to the first power needs to be represented also. So let's see if this is going to work. Doesn't really seem like it. So give me a minute. Let me make sure this actually works before we jump in and do this. Yeah, I think so. So let's bring down 1. 1 times 2 is 2. Add down the column and you get 2. 2 times 2 is 4. Add down this column and you get 5. 5 times 2 is 10. So I shouldn't have doubted myself. It works. Okay, so we already knew it was going to work, right? But the fact that the remainder is 0 just confirms what we already knew, which is what? 2 is a 0. Okay, so now we're going to move on to -2. Just make sure and use the reduced list. You don't start over at the beginning or you're not making progress. In other words, you're trying to whittle it down from whatever power it is to power of 2, so you want to keep going with that, okay? Because this is what I mean by the reduced list, right? This means x cubed plus 2x squared plus 5x plus 10. So we don't want to go back to our x to the 4th power thing. Let's go back to our x cubed thing instead. So notice this looks like 1, 2, 5, and 10. So if we bring down the 1, we get a 0 there, right? 0 times anything is just 0. Add that, we get 5, and -10, we get 0. So notice the remainder is 0. So we just confirmed what I already gave you, which is what? -2 is a 0 also. But the point was to get it down to this. Okay, so notice this is a little weird, right? So we don't have an x term. This is actually just x squared plus 5. So we just want to realize that there are 2 more zeros here. We just need to figure out what they are. Okay, so let's figure out what that looks like. So if we set x squared plus 5 equal to 0, we can't necessarily factor this. We could use quadratic formula. It's just that what is b going to be since it's missing? B would be 0. But you also can do something a little easier here if you'd like to. You actually can just solve since it's just plain old x squared. In other words, like I don't really need a full-blown factoring method if I can just remember some of my arithmetic rules. Okay? I don't really want x squared though. What would I prefer to have? X, right? So how do I get rid of x squared? Square root it. But when I do, just remember you have something important to make sure you include. It's positive and negative. So in other words, I end up getting x equals plus or minus the square root of I square root of 5. In other words, I can't break down square root of 5 at all. It's a prime number. And I just stick an I in there. Okay, you can also stick the I at the end, but typically we write the I in front so that it doesn't look like it's under the square root because it's actually not. Okay, so we're actually finished. Okay, so let's list what the factored form looks like. So here was my original equation. So what did I get for the 2 nice roots that I already knew about? X minus 2, x plus 2, right? Just to make sure you know which one's which, remember we're changing the sign here. This is the one for x equals 2. This is actually the one for x equals -2. And then we also ended up with x squared plus 5, which also did not factor further. So this is the factored form. By the way, this is not like a difference of squares. I can't factor it. It's not something pretty. And then what were my 4 zeros then? 2, negative, the order doesn't matter though, right? 2, -2, and then I had I square root of 5, but also what? Negative I square root of 5, okay? So these are going to show up on your graph as x-intercepts. These are not, right? And why aren't they going to show up? They're imaginary, right? These are not graphable. So when I look up this, if I try to check my answer on my graphing calculator, I am understandably not going to find those two imaginary ones, okay? So while you're finishing it up, let's look, you can just look up here at my calculator to kind of save some time, but it was x to the 4th plus x squared minus 20. So notice this funky graph crosses at what two spots? -2 and 2, and even if you zoom out, it never ever crosses again. Okay, it doesn't come back and cross again because the other two zeros are what? Imaginary and not graphical. Okay, so I guess I want to make the point that notice we're always finding the right number of roots. It's just that some of the zeros / roots might look weird like this. They might be not on your graphing calculator, okay? Notice your graphing calculator would do nothing to help you find these. Your graphing calculator would help you find these, but you got to be able to do this process to find the last two, okay? Also remember, how did we know that one example where the root repeated itself? How did we know, if we knew what we were looking at from the graph, that it was going to do that? Do you all remember? Yeah, it didn't come back, that's for sure, but it also turned. Remember how it turned on the x-axis itself? So that's another way that we know. So if you're doing your homework and you're like, I can't think of another route to try, you might want to try one that you've already done again, okay? So just kind of know that you are going to be able to use your calculator / I will probably give you problems like this, where I give you some guidance about where to start and you just have to finish out the problem. Okay, because that saves time, but it still shows me that you understand the process.